Hey team, just going to go through how to draw up the stool for an orthographic drawing. So orthographic drawing is when you have three different perspectives: the top view, the side view, and the front view, or the front view and the side view. These are interchangeable. As this product is a three-legged stool, there are two different views. If this was a four-legged stool, it would look the same for the front and the side view. We're going to have some design options when you're drawing up your stool. Make sure you draw up your stool so that it reflects your design options. Don't just copy what we're going to draw here. For example, some design options you have, the stool could be, so these legs could be shorter. Sorry, it's so close, but these legs could be shorter, or you could have them longer, a lot longer, okay? There is a maximum size as per what we're going to go through the drawing. The other design option we have is through hole legs. So you can see that the tenon, the male tenon, goes through the whole way to the top. It is easier. However, I personally don't think it looks quite as good. The other option is you have not through holes. So you have to stop the mortise and tenon joint before you go all the way through the top. So you can't see the legs through the top. However, it does fit in and stops before it goes through the top, like so. We're going to draw up some construction lines. We're going to draw up some invisible or hidden lines. So there are perspectives we can draw that we can't actually see. So for example, a dotted line on a drawing is a hidden line behind the back of it. The side view, so if we looked at the side view of this, you can't see any holes, but we know there's holes in there for that perspective. So if you do dotted lines as per here, it indicates that there are holes going through that on that view. All right, to start with, we need to make sure we know what our our scale is. So we're going to start with a scale that suits our piece of paper. I've generated this on CAD, so this is done on Fusion. You are welcome if you want. It's a free software that's able to draw up this. You can do this. I have a tutorial which I'll add in the notes, and you can go through and do it on Fusion if you really want. However, I'd encourage you to first do it by drawing with a hand drawing skills to draw orthographic. What we're looking for before we start: we need a sharp pencil. There's multiple sharpeners in the workshop. You need an eraser per table. You need a ruler. I would encourage you, if you don't know how to convert centimeters to millimeters, using a millimeter ruler. Please do not use inches. Inches are imperial. We only use metric. Unless you're in America, everyone else pretty much uses metric ruler measurements. A 30mm ruler will work best, as a 600mm ruler is twice as long and won't fit on that page. We're going to draw up all the same measurements. Our scale is going to be slightly different. This was computer generated, so I don't even know what scale this is. It doesn't include it. We're going to make sure we know what scale is. If we were to draw this up full scale, so that's a full scale leg, it's clearly not going to fit on that page. So we need to work out a scale that is going to fit. So if we did half scale, it would be half the size of that leg. Technically that would fit, but would only get one view. So we're going to pick a scale that is half that again. We could use a random one that's like 1:6 or 1:3. The maths gets really complicated for that. So what I encourage is a quarter scale. So we're going to divide every measurement by 4. To do that, first of all, let's write in block writing Milka's stool. We always use block letters, capital letters for all our text. We're going to do our name. And then we're going to do our scale, which is, in this case, 1.4. All right, that is our title block. We've got our scale. I'm going to put in here in brackets divide by 4, or a fraction of 4. All right, hopefully that helps. So our first measurement, we're gonna do the front view as per our drawing. Normally orthographic would be reorientated a bit different, but we're gonna do our orthographic this way. This one here is isometric. Isometric is when you can see the front view, the side view, and the top view all in one. We're only gonna do orthographic, which is our front view, our top view, and our side view when it's slightly rotated. So to start this drawing, we need to divide this measurement 300 by 4, which is 150, well 75 I'd say. So 75 millimeters across. And then I believe it's 40 mil down. So this is 40 mil from here to here. 40 mil divided by 4 is 10. So we do 10 down on both sides. This is another design option we've already got. We can choose to have this rounded chamfer. A chamfer is an edge that's rounded over with a nice curve. So as you can see on this one, there's this little curve, that's called a chamfer. We can choose to have that square. Personally, and I like the chamfer because it's softer and it's less likely to injure yourself. I think it adds a design detail as well. So I'm going to draw in that chamfer once I draw up that top. You can add it in after. So I've got 75 by 10. I'm going to close that in. All right. When I start drawing this, I try and do lines that aren't super thick or heavy, because when I then go to do my chamfer, and I'm going to do a measurement of maybe 2 mils, 2 mils there, 2 mils there, 2 mils there, 2 mils there. I'm kind of guessing this 2 mils because we're going to do a little curve here. Softly, we get an eraser, rub out that corner, and then re-pencil in that curve. So now we've got that nice rounded chamfered edge. And then we can go straight away and go to doing the next part of this, which is our legs. I think from memory they're inset by 40 mil. It's been a minute. No, 80 mil. 80 millimeters into the center to the outside. So 80 divided by 4 is 20. The center of our leg is going to be 20 mil in. And then I'm going to do a 20 mil on the other side. So that's the center of where our leg goes. And then our leg thickness at the top is 20. So we can have a look over here, is 22 millimeters. So that means 11 millimeters is going to go on one side, 11 millimeters is going to go on the other side. But we need to divide that by 4, which would be about 5, just short of 5. So I'm going to put it 5 mil. Is that right? 20, yeah. 5 mil that side, and I do a little line, 5 mil the other side. Same on this one, 5 mil there, 5 mil there. The leg goes down from the top 350 millimeters. This is another design option. So you can choose to have that longer leg or the shorter leg. So if you want, and the place I use it most is next to my couch, has a little table, a little coffee table or wine table, whatever you want to put next to your couch. You want the taller table. If you wanted a shorter leg like this one, this is a really good design for a pot plant stand. Same product, just modifying the design to suit your needs. I'm going to do the full length, and I'm going to struggle here. 350 divided by 4 is the full length down. Hopefully someone can calculate that. Oh, I'll start from here. Is 87 millimeters from the top, and I'm going to do a line straight down. 87 is there. So this is a soft line because this is the center of my leg. So we don't actually need to see this line. It's called a construction line. 87 millimeters down. I'm going to do another one. Now this is 90 degrees to the bottom. 90 degrees. No, it's not. I've already forgotten what I'm doing. That's right. Sorry. No, ignore that part. That is kind of correct, but we actually need to do that at an angle. I forgot what I was doing. So we actually need a construction line 87 millimeters down on the outside, if I remember rightly now. So 87, a soft line. A construction line is going to help us draw this drawing, but it's not actually part of the drawing. So it's a reference line. It's called a construction line, 87 millimeters down as well on this side. All right, so these construction lines, you can probably hardly see them. They go straight down 87 millimeters. So this is a line that is going to go straight down here to reference where the bottom of the leg touches. So now I know that from this point to this point, it must touch. So I can connect the outside of the leg to the outside of the stool. That's a actual line. And while I've got this set up, I know that there's a hole going through the center of my stool. I'm going to do a not through hole drawing, although the drawing on here is through hole. So I'm going to do, let me see, we'll do 8 mil. I think 8 mils in. We'll do dotted lines. This dotted line is the hidden line where the hole goes. And then I know the bottom is 40 mil. So 40 divided by 4 is 10. I'm going to do a soft line here because I'm going to also do a chamfer on the bottom of my leg. So I've got a relatively soft line so I can erase it. Then I connect this one to that leg as well. All right, that's one leg done. Why does it not look so tapered? 45, 10. Something does not look right. Anyway, let's play on. 22 divided, yeah, okay. And then we'll do another one that connects this one to the bottom. So it should be on the bottom of that. I can do a little soft line, construction line to give me guidance where it's going to go. Connect that up to that intersect where the construction line is. That's 40 mil divided by 4 is 10. And then I can connect that one up too. Alrighty, so now we've got our 2 outside legs. We can then do the middle leg, which will be halfway in the middle of this. Half of 75 is 37. Alright, I can do a construction line if I wanted. And that's straight down. So this will be the middle leg, and then I'm going 10 mil, which either side of, or 5 mil either side of that line. Same with the top. Doesn't seem quite right. It's just smaller at the top anyway. And then I can connect those ones up as well. Cool. And then I have my 3 legs done. I can continue those lines up to do my dots where the hole will go through. This is hidden. So as I said before, there's holes in here. We're going to make sure we can see the X-ray version of that, which is these dotted lines. And as long as they finish all at the same point, that's what the dotted lines indicate. And then I'll do a dotted line to close off the top of those legs. Dot, 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 dot. And in fact, we've got wedges. If it's through hole, so if the hole goes all the way through, we can put wedges in, which makes it stronger. We can't do that with the not through hole, so I'm not going to draw wedges. If you have done your legs all the way through the top, you'll need to draw the wedge as per on this drawing here. All right, to finish off this drawing, I'm going to do a little curve so I could measure if I wanted maybe 2 mil or 1 mil this time, and 1 mil, 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 and then curve it, curve, 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 curve. So then I'll erase the very corners. Thanks, Mr. Murphy. All right. Round that off to get a nice rounded bottom. Okay, and that is now our top view complete. Oh, sorry, our side view. Side view done to 1 to 4. We're going to do some more construction lines. I'll just wait for this announcement.
Make their way up to T block for rehearsal. That is students in beauty school dropout seat to T block for rehearsal.
Thanks, Miss Maud. I'm going to do some more construction lines to project these down. Miss Maud, can you remind me, is the orthographic...
You're doing it wrong.
I'm doing the wrong...
Yeah.
What is it?
So front, side, top.
Yeah. So you can do it that way. I'm going to keep doing it this way because we're going to copy this, the one I did before. All right, so now we're going to do the top view. For the top view, you will need a compass that can do a circle, or you can use a circle finder or a circle projector. All right, so we've got protractor to do the next one. I'm going to project a construction line through the center of this drawing as well. We should have done one for our stool. A nice light line. It's an invisible line that we're going to use. And then halfway down, we can do our circle. Cool. That line is, or should be, about 75 mil wide, which is the scale we're doing it to. It should also fit inside of our projected lines. If I'd done that projection line correct, that should be inside of that, which is the same diameter as that. All right, we've got our legs. Then we're going to do, to place our legs, we need to do our setup for where our legs go. So with the radius set, so radius is half the diameter, we put it on there and we run it around the edge like so, intersecting at the same radius, like the projector legs, or sorry, the compass legs are set to the radius, and it should intersect 6 times if I've got this right, which is handy because we've got 3 legs. And then the last one will be slightly over because pi isn't friendly with us. But now we've got 6 intersects. We only need 3, so we've got this one, and this one. We're going to ignore these 2. And then we're going to go from the center in and do a construction line again. A nice light line to intersect it into thirds. Nice light line. And we've already got that line. 10 mil in, which is 20 mil in.
From 10C, please make your way to middle school now. Thank you.
So 20 mil in, which would be 80 mil to the center. Same here again, 20 mil. Fair way in along that line, 20 mil here. In fact, it could choose to do that 15 mil. That seems pretty deep. Anyway, that's all right. And then our top of our legs, 22 divided by 4, 6. So we're going to do a circle that is about 6 mil. So you can set up a compass and do it. I'm just going to sketch this one in. That's all right. Same with this one. 6 mil, which is either side of it. Same with this one. 6 mil, center of the 6 mil. It's about there and there. So we've got our top of our tenons. Now, because mine isn't all the way through, these should be hidden lines. So if they're hidden lines, they're going to be dotted lines. If you're going all the way through, these could be solid lines. So dotted line, that would be a dotted line too. Then out from there, I'll need my legs to project slightly out. And they go out 10, so I go 5 either side, which is 5. Oh, that's imperial. Let's go metric. 5, 5. 5, 5. So I'm just doing light lines to tell me where I'm going to put my lines coming out. And they come out, let's put them out 5 mil just to show them. 5 mil coming out. So this is just showing that the legs from the top view are going to be splayed out a bit further than the top view. If you make your top bigger than how far you splay it, you wouldn't see these legs coming out at all. So that's just a design preference. All right, I've got my legs coming out and I'm going to do a little curve like so. So I've got my top view. Because we need to glue, I think it's a bit easy to see here, we need to glue multiple bits of timber together to make this bit of timber. We're going to actually do those lines. Each one of those lines is 40 mil, so every 10, 10, 20, is that right? 1, 2, 3, 4, 5, 40, it's more than 40, oh, 90. 90 divided by 4 is 45, what's half of 45? 22. Every 22, that makes sense. So every 22, I'm actually going to mark a line. 22, 22, 22, and a little one. So as per what you're making, there's a line there, a line there, and a line there. So you should have had 3 big ones and 1 half one. All right, the last view we're going to do, we're going to project this bottom over. So this is the front, or sorry, the side view or the front view. Project that one across, a nice light line. Project that one across. And in fact, I'm going to rename that one to the front view. That makes more sense, as the front view is the most dominant. Front. And then this one will be the side view. This is the top. All right, so good news for the side view. The side view, I'll demonstrate what the front view looks like. So it's probably can't see everything in here. That's the front view. That's the side view. Okay, it's just slightly rotated. So the top doesn't change. We can draw the top exactly the same. So that was 75. Somewhere over here, I'm going to draw 2.75. 10 mil down.
Excuse me, everyone. Could the Year 11 captains and Year 12 prefects please make your way to student services?
Same again, I'm going to do that
Year
curve.
11 captains and Year 12 prefects to student services. Thank you.
And then as per this one, the legs are inset on a slight angle. The outside leg is slightly different. So we're just going to put that in 10 mil this time. Did we do 10 mil last time? Yeah, no, different. Sweet. 10 mil this time. We have our construction line. It sits the same. Nice light line. Then an intersect. Connect that up with a heavy line. 10 mil, which would be 40 mil in real life. Should have done that a bit lighter. 2 is 5. It's 6 mil at the top. Yeah, that's where I went wrong. So this actually should be 6 mil at the top of our leg. That's where it should be tapered. Yeah. Cool. And then this next one I'm going to do in 20 mil. Construction line again. So this is going to be just a reference line, and then 5 mil in from that construction line. Then we're going to connect those two dots. And we only need to do one leg here because the other one's hidden behind that. 10 mil across here. That's actually 5 mil, 6 mil-ish. Connect that one up. And we've got this other leg hidden behind that leg, so we're not going to show that view. We could then do our dotted lines to show the same as this one. Top of this one, some dotted lines to connect them up to indicate it's not through hole. Cool. The last thing we need to do is do our actual measurements. So we do some light guidelines to indicate our actual sizes, because you won't have access to this. You'll need to use your own design to draw yours up. In your neatest handwriting, try. My handwriting isn't super neat, so I'm assuming that most people will be neater than mine. We're going to draw the actual measurements, not the scale measurements when we do dimensions. So these are called dimension lines, what we're doing now. That one is 40. The top of our leg is 22. If you get more time, I strongly encourage you to do a leg by itself, like in this drawing. And if you get even more time, you can have a go at doing an isometric. So you could probably fit an isometric in here, and your leg, as per the drawing, would fit in over here. This drawing is complete once you have as many dimension lines as you'll need to make it. So this one was 300. I'm going to go through and draw all these dimension lines as per the drawing that's handed out. In fact, I might encourage you to do a few extra lines. That is actually 90, not 65. Don't know why that's 65. Oh, that's different material. So this drawing was used different material. So there's 1, 2, 3, 4, 5. We're only using 3 plus 1. So we're using 90 mil wide timber, not 65 mil as per that drawing. You can also do points. So this one is diameter sign is an O with a line through it, equals 22 at the top. Oh, 22, not 20. And the bottom of the leg is 40 mil. So that indicates there. We don't need to dimension everything, so we can assume if that leg is the same as that, we don't need to do a dimension for every leg because they're all identical. So as long as, if we want the measurement for this one, we can see that it's the same as that one, so we've already got it there. The thickness of this, we can do a dimension line along it. So I'm going to do an intersect here. That is approximately 40 mil. Notice I haven't written millimeters on anything. So the last thing we need to do, once we finish all this, is write all measurements in in millimeters. So we don't need to then write millimeters against every number because it's inferred as per that up there. I think that's mostly complete. I'm going to ask you guys to go through and now put all your dimensions in by yourself. But that is how to do an orthographic drawing with a front, top, and side view complete.